Well, welcome back. In this lesson, we are going to look at solving proportions. And there's a couple of new vocabulary words that we need to get out of the way first. And one of them is equivalent ratios. Equivalent ratios are like equivalent fractions. In fact, the word ratio and fraction can be substituted one for the other. So equivalent ratios are ratios that simplify to the same ratio. A proportion is basically two fractions that are set equal. It's an equation, but it involves two fractions, so two fractions that are equal to each other. A cross product is a diagonal product that we use to solve proportions. And a constant of proportionality is basically a unit rate, which we've talked about in another lesson, and that's always in a proportional relationship. So first off, a proportion. A proportion is an equation stating that two ratios or rates are equivalent. And what that means is basically that we have two different fractions separated by an equal sign, and we're going to focus on how we solve those kinds of equations. So here's an example. We're using temperature. After 2 hours, the air temperature had risen 7 degrees Fahrenheit. Write and solve a proportion to find the amount of time that it will take at this rate for the temperature to rise an additional 13 degrees. So the temperature rose positive 7 degrees, and the time factor was 2 hours. So our time is in hours, and our temperature is in Fahrenheit. We want to know how long, how much time it will take, to rise an additional 13 degrees. So we need to be consistent. Temperature on the top, time on the bottom equals temperature on the top, time on the bottom. And the way that we solve proportions is we do what's called the cross product. So we're going to go ahead and we're going to multiply diagonally. 7 times t is equal to 2 times 13. Using those cross products, we will come up with the next equation. 7t equals 2 times 13, which gives us 26 on the right. And now you know how to solve these equations. T is being multiplied by 7, so we want to undo that. And the opposite of multiplication is division, so we divide by 7 on both sides. Those 7's cancel out on the left, and we get t is equal to, in decimal form, we get 3.7. So it would take 3.7 hours to increase that temperature an additional 13 degrees. Here are 3 more problems for you to try using proportions. Go ahead and solve these, and I'll give you your answers when you come back. All right, I hope you gave those a try. So letter A, you should end up with 10x equals 36 and x equal to 3.6. Letter B, you get 2y is equal to 5 times 34, which is 170. So y is equal to 85. Letter C, we get 3n equals 14.7. When you multiply 7 times 2.1, you get 14.7. So n is equal to 4.9. Making predictions. During a blood drive, the ratio of type O donors to non-type O donors was 37 to 43. These are the type O donors, 37. 43 were non-type O donors. How many type O donors would you expect in a group of 300 donors? So the tricky part of this, we have 37 type O donors, but our total donors includes both the O-type donors and the non-type O donors. So that's a total of 80 donors. So we have a ratio of 37 to 80. So we're going to take 37 over 80 is equal to how many over 300? And then we're going to do the cross products. 37 times 300 is 11,100. And then we have 80 times x. To get x by itself, we need to divide both sides by 80, giving us a value of 138.75. So we can't have part of a donor, so we're going to round that up to 139 donors. Here's a recycling problem. It says recycling 2,000 pounds of paper saves about 17 trees. Write and solve a proportion to determine how many trees you would expect to save by recycling 5,000 pounds of paper. Well, let's go ahead and start out. We have 2,000 pounds, so we're going to put pounds on the top. Saves about 17 trees. So pounds are on the top, trees are on the bottom. And that's going to equal, on the right-hand side, I'll put this one in red, 5,000 pounds. And we don't know the number of trees. We'll call it x. Okay? So let's see. Do we have any work? Oh, we just have, yeah, we do. So over here we have, oh shoot. So we have 2,000 equals 5,000. 2,000 over 17 is 5,000 over x. When we cross multiply, we thought I might have the work in here, but I guess I don't. So we're going to multiply 2,000 times x. We'll get 2,000x is equal to 5,000 times 17. Excuse me. And 5,000 times 17 is 85,000. So now we need to divide both sides by 2,000. So these end up crossing out and we get x is equal to 85 divided by 2, which is 42.5 trees. And there you have it. You can also use the constant ratio to write an equation expressing the relationship between two proportional quantities, and we call that the constant of proportionality. So here's a gasoline problem. It says JC bought 8 gallons of gasoline for $22.32. Write an equation relating the cost to the number of gallons of gasoline and how much would you expect her to pay for 11 gallons at the same rate. So we have 2232 over 8 is equal to x over 11. Whoops. This would give us $2.79 a gallon. So our cost in dollars is going to be C. We're going to write an equation for this one. I jumped the gun there for a second. So our cost will be $2.79. That's our rate times the number of gallons. So we're going to take that times 11, giving us $30.69. So the point of showing you this, there are two ways you could solve this problem. You could set up a proportion like we did in the last slide, or you can use an equation finding this unit rate and multiplying by the number of gallons. Here's another example using a typing example. Olivia typed 2 pages in 15 minutes. This one we want to write an equation relating the number of minutes m to the number of pages p that she typed. If she continues typing at that rate, how many minutes will it take her to type 10 pages? And how many minutes will it take her to type 25 pages? So her rate, we want to find the rate. How long does it take her to type a page? So we have 15 minutes. And she does 2 pages. And that gives us a rate of 7.5 minutes per page, right? So if we want to find out how many minutes will it take, it says we need an equation. Write an equation relating the number of minutes to the number of pages typed. Excuse me. So how long would it take her to type 10 pages? So m is equal to 7.5p. So this is her rate, okay? And this is your equation. The number of minutes is equal to 7.5 times the number of pages. So to do 10 pages, you're just substituting in the number 10 for the letter p. So if we have m is equal to 7.5 times p. So in the first example, you want m equals 7.5 times, and then I'll put this in a different color so it's easy to read, times 10. So m works out to be 75 minutes. In the second example, we have m is equal to 7.5 times, and this time instead of 10, we want 25 pages. So m is equal to 187.5 minutes. All right, here's your chance to see if you understood any of what we were talking about in this lesson. The first 3 problems, you're solving proportions using cross products. And for problems 4 and 5, you're assuming that the situations are proportional. And number 4, you need to solve using a proportion. And number 5, you're going to write an equation. So you're going to do one of each type. Bring your answers to class and we'll see you next time.